Now I will discuss about the topic binomial theorem. First of all, what is binomial theorem? Bi means two term का theorem, that is called binomial theorem. Here, the pattern of numbers was already known to the European mathematician of the late Renaissance, including Stiefel, Niccolo Fontana, Tartaglia, and Simon Stevin. And Isaac Newton is generally credited with the generalized binomial theorem. It is valid for any rational exponent. Isaac Newton, that is credited. But after some day, also Blaise Pascal details it is explained. So that's why father of a binomial theorem is Blaise Pascal. That is 1623 से 662 के अंदर वो निकला. So that is it. Binomial theorem. What? The bi means two term, that is a plus b, that is two term. The binomial term ka power, that is nth power, whether n is rational or irrational. That is here only rational exponent concept is given. So nc0 a to the power n minus 0 b to the power 0 plus nc1 a to the power n minus 1 b to the power 1 plus nc2 a to the power n minus 2 b to the power 2 plus dot 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 ncn a to the power n minus n b to the power n. This is called binomial theorem. This is called binomial theorem. This is described by Pascal. Here, you know that very well, a plus b to the power 0. If the exponent is equal to 0, the value comes 1. If the exponent is equal to 1, the value plus simple a plus b. A plus b ka whole square, you know that a square plus 2ab plus b square. Similarly, a plus b ka whole cube is equal to a cube plus 3 a square b plus 3 a b square plus b cube. A plus b to the power 4 plus a4 plus 4 a cube b plus 6 a square b square plus 4 a b cube plus b4. A plus b to the power 5 is equal to a fifth plus 5 a fourth b plus 10 a cube b square plus 10 a square b cube plus 5 a b fourth plus b cube. That means here why it is written, that means inside that some logics are there. That is the coefficient logic. Here coefficient 1, here coefficient 1, here 1, 2, 1, here 1, 3, 3, 1, here 1, 4, 6, 4, 1. Similarly 1, 5, 10, 10, 5, 1. These are the coefficients. That means whatever the index is given, according to the index, there are some coefficients are there. Actually, this pattern is described by Pascal. So that pattern forms a triangle. So that's called Pascal's triangle. Now discuss in Pascal's triangle. This is a Pascal's triangles. How? If index is equal to n, index coefficient is given here. Index if 0, here index is 0, that coefficient is equal to 1. Here index is equal to 1, that coefficient is equal to 1 and 1. Here index is equal to 2, that coefficient is equal to 1, 2, 1. Here 1, 2, 1. If index is equal to 3, coefficient is equal to 1, 3, 3, 1. 1, 3, 3, 1. If index is equal to 4, coefficient is 1, 4, 6, 4, 1. Here 1, 4, 6, 4, 1. If coefficient is equal to 5, so index is 5, coefficient is equal to 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. That's why this is the index. Similarly, if the coefficient index is equal to 6, that is equal to 1, then this sum is equal to, that is 6, this sum is equal, this is equal to 15, this sum is equal, that is 20, this sum is equal to, that is equal to 15, this sum is equal to, that is equal to 6. So then 1. So in this way we can find out another index and a coefficient value. It is forms like a triangle, so that it is called Pascal's triangle. So it is called Pascal's triangle. Pascal's triangle. Okay. So similarly, we can find out the more index, whatever the index will come, you can find out. Just like you follow it, what the follow is there. This is the 1 plus 1 that is equal to 2. 1 plus 2 that is equal to 3. 2 plus 1 that is equal to 3. 1 plus 3 that is equal to 4. 3 plus 3 that is equal to 6. 3 plus 1 that is equal to 4. 1 plus 4 that is equal to 5. 4 plus 6 that is equal to 10, 6 plus 4 that is equal to 10, 4 plus 1 that is equal to, similarly here 1 plus 5 that is equal to 6, 5 plus 15, 6 that is equal to, that is 10 that is equal to 15, 10 plus 10 that is 20, 10 plus 5 that is equal to 15, 5 plus 6 that is equal to 5 plus 1 that is equal to 6. So in this way that the value will come. This is the Pascal's triangle. If index is given, you can find out the coefficient. Similarly, that coefficient you can find out in combination format. How can we find out the combination format? That means you think about the combination format. Means here that is equal to 0C0. Then 1C0, 1C1. Then similarly, this is equal to 2C0, 2C1, 2C2. Similarly, 3C0, 3C1, 3C2, 3C3. Then 4C0, 4C1, 4C2, 4C3, 4C4. Similarly, 5C0, 5C1, 5C2, 5C3, 5C4, 5C5. Then 6C0, 6C1, 6C2, 6C3, 6C4, 6C5, 6C6. These are the basic values, that is 0C0. These are the basic values which is in form of a combination. ये combination format है, ये normal format है. You can find out easily. 0C0 that is equal to 1, 1C0 that is equal to 1, 1C1 that is equal to 1, 2C0 that is equal to 1, 2C1 that is equal to 2, 2C2 that is equal to 1, 3C0 that is equal to 1, 3C1 that is equal to 3, 3C2 that is equal to 3, 3C3 that is equal to 1. Similarly, 5C0 that is equal to 1, 5C1 that is equal to 5, 5C2 that is equal to 10, 5C3 that is equal to 10, 5C4 that is equal to 5, 5C5 that is equal to 1. In this way, we can find out the combination value. Then if there is value only constant is there, we can generate in combination coefficient format. So how, now that is the combination coefficient format we can take if the more than, suppose 10 index is more than 10 or 100 or whatever the index value is greater, on that time you can take that a combination format, because on that time you cannot calculate in coefficient. Okay, in shortly you can calculate in a large number case. So that's why we cannot take if index is more, only we can take in combination format. That is okay. The structure given in the above figure looks like a triangle. This array of a number is known as Pascal's triangle, after the name of a French mathematician Blaise Pascal. It is also known as Meru Prostara by Pingla. Pingla actually said that is Meru Prostara. Some books is Meru Prostara, and that book, that structure format is given. So, which is also looks like a Pascal's triangle. Okay. Here, if you take one example, 2x plus 3y to the power 5. That is 2x to the power 5 plus 5 into 2x to the power 4 3y plus 10 into 2x to the power 3 3y square plus 10 into 2x square x का whole square 3y का whole cube, then 5 plus 5 into 2x into 3y to the power 4 plus 3y to the power 5. That means here 32x to the power 5 is 2 to the power 5. Similar 240 x to the power 4y plus 3 720 x, okay, x cube y square plus 1080 x square y cube plus 810 x y to the power 4 243 y to the power 5. After the expansion, here similarly another question, by using binomial theorem we can find a plus b to the power 7 is equal to 7c0 a to the power 7 b to the power 0 plus 7c1 a to the power 6 b to the power 1 plus 7c2 a to the power 5 b to the power 2 dot 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 plus 7c7 a to the power 0 b to the power 7. Okay, that is the expansion by taking combination format. You know that here NC0, NCR is equal to n factorial divided by n minus r ka factorial into r factorial. Okay, if the binomial theorem is expansion, if the number n is by index n is positive integer, then what the expansion said? Okay, here binomial theorem for any positive integer, that means a plus b to the power n. Here n is a positive integer, maybe 2, 3, 4, 5, 6, 7, 8, 10. That is whatever the positive integer. That is nc0 a to the power n b to the power 0 plus nc1 a to the power n minus 1 b to the power 1 plus ncn a to the power 0 b to the power n. So it can be proved by mathematical induction method. It can be proved by mathematical induction, means n is equal to 1, whatever the value is true. N is equal to k, let it is be true. Then n is equal to k plus 1 by using okay k, then you can prove that total value. So similarly, you take now an example. X plus 2 sixth power, that is equal to 6c0 x to the power 6 2 to the power 0 6c1 x to the power 5 2 to the power 1 6c2 x to the power 4 into 2 to the power 2 plus 6c3 x to the power 3 into 2 to the power 3 plus 6c4 x to the power 2 into 2 to the power 4 plus 6c5 x into 2 to the power 5 plus 6c6 x to the power 0 into 2 to the power 6. Means here this is 0 1 2 3 टोटल ये इंक्रीजिंग ऑर्डर में गया है. सिमिलरली हियर 6 कम होके 5 4 3 2 1, दिस इज डिक्रीजिंग ऑर्डर में गया है. और 2 का पावर 2 0 1 2 3 4, दैट इज इंक्रीजिंग ऑर्डर में गया है. ओके, इन दैट वे वी कैन फाइंड द ओके व्हाट बाइनोमियल थ्योरम का इवन sorry positive integer का value expansion means x to the power 6 plus 12x to the power 5 plus 60x to the power 4 plus 160x cube plus 240x square plus 192x plus 64. That means here after the expansion the value comes. This is a simple one example is given. So similarly some properties is there. You can find the properties. Okay, some property you can find the property, what the different properties by using that property. Actually every mathematics there is two concept is given. One is the definition, another is the property. If you know definition very well and properties very well, then you can apply okay the concept in easily, and you can do the fundamental problem very easily. That doesn't mean that is you don't know the other concept. No, that is the definition, property. According to that, you can do other concept also. Some observations and properties. or properties. Observations or properties, that is here summation k equal to 0 to n nc k a to the power n minus k b to the power k plus is equal to nc0 is equal to nc0 is equal to nc0 a to the power b, okay, a to the power n, b to the power 0, nc1 a to the power n minus 1, b to the power 1, plus dot 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 ncn a to the power 0, b to the power n. Where n is index or exponent and b to the power 0 is equal to 1, a to the power 0 is also 1. So a plus b ka expand to the power n, that is expansion, that is in binomial theorem, k is equal to 0, n summation k equal to 0 to n, nck a to the power n minus k, b to the power k. When k equal to 0, then first term k is equal to 1, then second term k is equal to, that is third term k is equal to n, that is nth term is there. Okay. Similarly, n plus 1th term is there. So here NCR is called binomial coefficient. If index is n, then total number of terms is equal to n plus 1. If index is equal to 5, then total number of a term is equal to 6. If index is equal to 4, then total number of a term is equal to 5. Similarly, if here an index is n, then total number of a term is equal to n plus 1. Now the r plus 1th term, that is a t r plus 1 means term r plus 1, ncr a to the power n minus r, b to the power r. Sum of exponent of x, y in any term is equal to n. Here this term, n plus 0, that is equal to n. n minus 1 plus 1, that is equal to n. Similarly, 0 plus n, that is equal to n. Sum of exponent of x and y, or a and b. Here a and b in any term is equal to n. Is equal to n. That is the some properties. Some special properties are there. We can find the some special properties. What the some special properties? Some special properties, that is given here, that is equal to x plus y to the power n expansion if taken, replacing y with minus y, then x minus y to the power n, written as x plus y minus y whole to the power n. So nc0 x to the power n, y to the power 0, minus nc1 x to the power n minus 1 y, plus nc2 x to the power n minus 2 y to the power 2, plus dot 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 minus 1 to the power n, ncn x to the power 0, y to the power n. So similarly, another property, 1 plus x to the power n is equal to nc0, nc1x, nc2x square plus dot 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 ncn x to the power n. We can say ncn is equal to cn, nc1 is equal to c1, nc2 is equal to c2, nc3 is equal to c3. Means you can say that is c0, c1x, c2x square plus dot 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 cnx to the power n. We can write also. Similarly, 1 minus x to the power n, nc0 minus nc1x, nc2x square plus dot 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 plus minus 1 to the power n, ncn into x to the power n. We can write also similarly c0. We can write c0 minus c1x plus c2x square plus dot 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 plus minus 1 to the power n cn x to the power n. We can write also here if to x plus y to the power n plus x minus y to the power n is equal to, that is to added, that is 2 into nc0 x to the power n plus nc2 x to the power n minus 2y2 plus dot dot. Means odd terms and even places are solved. Okay, deleted, remaining what sum of terms at odd places ये ट्वाइस रह जाएगा, इसका मतलब है ट्वाइस इनटू सम ऑफ टर्म्स एट ऑड प्लेसेस. That's why last term will come NCN y to the power n if n is even, and NCN minus 1 x y to the power n minus 1 if n is odd. Similarly, x plus y to the power n minus x minus y to the power n, if you write, that is same concept, but whatever NC0 x to the power n, either NC1 x to the power n minus 1 plus NC2 x to the power n minus 2 y to the power 2. Similarly, sum of terms at even places, ये दो बार आ जाएगा, तो 2 into sum of terms at even places. The last term of the expansion or subtraction, NCN minus 1 x y to the power n minus 1 if n is even, and NCN y to the power n if n is odd. These are some special property. If you think about another also properties there, that property is here if 1 plus 1 to the power n, if you put it here, that comes C0, C1, C2, C3, dot, 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 Cn. Similarly, that's why that value comes 2 to the power n, C0, C1, C2, C3, dot, 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 Cn. Same concept, if you put in the place of x, that is minus, so that 1 minus 1, here if you put that x plus 1, that is equal to C0 minus C1 plus C2 minus C3 plus dot 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 plus minus 1 to the power n Cn. That's why the value comes 0 is equal to C0, C1, C2, C3 dot 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 minus 1 to the power n Cn. So by adding these two are adding, it is formed by adding, it comes to 2 to the power n is equal to what? 2C0, 2C2, okay. Similarly, 2C4 plus a dot dot dot, the value comes. That's why the value of a function, expansion will come, that is twice of C0, C2, C4, dot, dot, dot. It means either 2 to the power n, this 2 comes this side also. So 2 to the power n minus 1 is equal to C0, C2, C4, dot, 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 value will come. If you think about the odd places, if you here subtracted, that is 2n is equal to C0, C1, C2, C3 plus dot 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 Cn subtracted, that is equal to C0, okay, minus C1 plus C2 minus C3 dot 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 minus 1 to the power n Cn. By subtracting, what value will come? That is here 2 to the power n, that means here 2C1, 2C3, 2C5 dot 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 value will come. That means if you taking common, the 2 taking common C1, C3 dot, okay, C5 dot 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 value will come. That means 2 to the power n is there. That's why 2 to the power n minus 1 is equal to C1, C3, C5 plus dot 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 value will come. This is also one concept. This is also one concept. Here even terms odd places, here odd terms even places. That means C0, C0. Okay, that's value will come. This is also a special properties. Here, one question. Expand x square plus 3 by x to the power 4. when x is not equal to 0. Now, answer x square plus 3 by x to the power 4 is equal to 4c0 x square का whole 4 plus 4c1 x square का whole cube into 3 by x 4c2 x square का whole square 3 by x का whole square plus 4c3 x square का power 1 3 by x का power 3 then 4c4 3 by x to the power 4. Okay, by expansion, that is 4c0, that is 1, x to the power 8, 4 into x to the power 6 into 3 by x, then 6 into x to the power 4 into 9 by x square, plus 4 into x square plus 27 by x cube, plus 81 into x to the power 4. So here, the value x to the power 8, plus 12x to the power 5, plus 54x square, plus 180 by 8, x plus 81 by x to the power 4 value will come. This is the expansion value. When we expand the x square plus 3 by x to the power 4, the value comes this, that is x square 8, 12x to the power 5, 54x square plus 108 by x plus 81 by x to the power 4 value will come. Another question is you take, that is some typical question. If the sum of all terms be A and that even terms be B, that means if we expand x plus y to the power n, one is odd term, another even term. So odd term is A, another even term is A, B. The sum is given that A plus B. Similarly, x minus y to the power n, that is equal to one is even, one is odd. Another, that means term that is the odd terms minus even term. So odd term that is equal to A, even term that is equal to B. So A minus B value will come. So according to question here, 4AB is equal to what? You know that 4AB is equal to A plus B का whole square minus A minus B का whole square. So A plus B का value कितना ना x plus y to the power n, you put it here. A minus B का whole square, that is the x minus y to the power n का value, you put it here. After that, x plus y to the power 2n minus x minus y to the power 2n value will come. If the option is given in this way, you tick this option only. Okay, this is the concept. Now we expand the other concept. Means if a number is given, means 91 terms is given, 91 to the power suppose 5, some concept is given. From that time, what will we do? Okay, like this here. Here 9.8 to the power 5. If you find out the value, 100 minus 2 to the power 5. If 99 to the power 5 is given, so 100 minus 1 to the power 5. So that 101 is given, so 100 plus 1 to the power 5. Similarly, here 5c0, 100 to the power 5 minus 5c1, 100 to the power 4 into 2 plus 5c2, 100 to the power 3 into 2 to the power 2 minus 5c3 into 100 square into 2 to the power 3. Here plus 5c4, 100 into 2 to the power 4 minus 5c4, 2 to the power 5. So that here value comes, that is 1 ka 10 0 minus 5 into 1 ka 8 0 into 2 plus 10 into 1 ka 6 0 into 4 minus 10 into 1 ka 4 0 into 8 plus 5 into 1 ka 2 0 into 16 minus 32. That value comes, some terms use, okay, so plus term you add it, minus term you add it. 1 0 0 4 0 0 8 0 0 minus 1 0 0 8 0 0 3 2. The value comes 9039 207 968 value will come. Another example, if you think which is greater or which is smaller, we have to find out which is larger. Which is larger, 1.0 to the power 1 million or 10,000? So 1.01 to the power 1 million, if you expand, you taken that is 1 plus 0.01 to the power 1 million. By binomial concept, 1 million C0 plus 1 million C1 0.01 plus 1 million C2 0.02 to the power 2, then 1 million C3 0.03 by 3 dot 1 million C 1 million 0.01 to the power 1 million. So here the value is 1, here the value is 1 million into 0.01, and other terms are positive terms. So that's we have to write simply other positive terms. If you add that no change और ये less नहीं होगा, suppose कुछ positive term add करेंगे तो वैल्यू डिक्रीज नहीं होगा, कम नहीं होगा तो बढ़ेगा, इसीलिए other positive term लिख दिया. Then 1 plus the value comes 10,000 and other positive terms. So that 10,001 plus other positive terms will come. 10,001 already 10,000 से ज्यादा, positive term add होने से और भी ज्यादा हो जाएगा. So which is that means 1.01 to the power 1 million is greater than 1,000, sorry, greater than 10,000 value. So this is the okay, now completed. After that I will say, or another video I will give the idea about the general term, middle term and independent term of x, okay, and some expansion I will tell. Okay, please subscribe and share and bell घंटी दबाओ for update information quickly, okay, or better notification. Please share and subscribe. Okay, thank you.